Ladies and gentlemen, welcome and thanks a lot for joining us today for the latest in our Freight Carbon Zero webinars. As you probably know by now, my name's Andy Salter. I'm the editor of Freight Carbon Zero, and I'm here as your host today to take you through the topic in hand. As you can probably tell, we're here at the home of DAF Trucks in the UK, and I'm joined by Adam Bennett from DAF, from Tom Allerton from Cenex, and from Chapa Chandrasekhara. I've been practicing that all morning. I really apologise for that. And you're from Cenex. You've been partners, all three of you, and we're going to be joined as well by an operator from Unipart who's been part of the battery electric truck trial. That's the topic of today's webinar. Those of you that have joined our webinars previously will know that we've been started our first series around decarbonisation 101. We're trying to simplify the big topics associated with the decarbonisation of the road freight and commercial vehicle sector. We're now moving on to a new series called Decarbonisation Insights, when we want to look at some of the case studies, some of the projects, some of the trials that are going on around the industry and share the information and learning with you, the market. And that's why we're here. We're here to understand what's been going on with the government-funded battery electric truck trial. The final report is imminent, I understand. It should be published in the next few days. But we've got our experts together today to give us a sneak preview of the reports and the findings from the report. So, Adam, we're going to start with you. Then we're going to come to Tom and Chapa, and you're going to take us through the trials. Then I'm going to ask Graham, who was unable to join us today from Unipart, to give some of the operational insights. And then it comes down to questions from you. You know the drill by now. Use the Zoom platform. Please put your questions in using the platform, and I'll do my best to go through. We've got lots of people on the call today, and I'm sure we're going to get lots of questions. We might not get room for them all, but I've asked the team here to stay behind after the hour, and we'll try and get through any of the outstanding questions if there are any. So, go on, Adam. Take to the stage, and let's hear what you've got to say.
Good morning. My name is Adam Bennett. I'm the EV and Sustainability Manager for DAF Trucks UK. And this presentation is all around the results of the battery electric truck trial, which began in April 2022. So I'll start with a brief introduction about what the project was around, before inviting Tom and Chapa in from Cenex to go through the results of the trial and the key learnings. And then I'll come back on and just provide a bit of a conclusion and what it's meant for DAF Trucks UK and what we've achieved post-trial, utilising the results and the experiences. So I'll move it along. You can see on screen a summary of the project itself, which was funded by Innovate UK under the SBIR ZE road freight competition rules. And it enabled DAF UK to place 20 of our Phase 2 electric LF vehicles, which were 19-tonne rigids, into the NHS supply chain and local authorities. And this project now has been running for 18 months, and we'll go into some of the key learnings and the results when Tom and Chapa come up. So from a project partner perspective, it was Innovate UK that provided the funding for the vehicles, the charging infrastructure, and all of the monitoring equipment, tools and software. And we've been having regular review meetings throughout the project. We then have DAF and Leyland Trucks, and we were responsible for manufacturing the vehicles, procuring the charging hardware and software, and delivering the vehicles into the fleets, including the driver training that was required for the end users. And the data collection was subcontracted to Cenex, who you'll hear from shortly. And Cenex provided the systems and tools to capture and analyse the data, both from the vehicle, the driver, and from the charging infrastructure. And we can see some deep dive reports that have been produced periodically throughout the project, which you'll hear about today. You can see on screen now some of the participating fleets. So you can see top left there, we've got Blackpool Council, which utilised one of the electric vehicles for moving their iconic illuminations. SPO, based in Leicester, which were delivering goods into the public sector. You've then got NHS Leeds hospitals, teaching hospitals who took 2 vehicles for delivering bins to and from their hospitals. NHS supply chain with 8 vehicles across Rugby, Alfreton, Normanton, Bury St Edmunds, and they're supplying or been using the vehicles to deliver supplies into their hospitals. NHS Northern Care Alliance, 2 vehicles based up in the north delivering bed linen to and from the hospitals. We have Rochdale Council, which are using the vehicle for wheelie bins. Tameside Metropolitan Borough, using again the vehicle to deliver wheelie bins. We have a vehicle in Birmingham with the NHS looking to supply, using the vehicle to deliver supplies to that particular hospital, and 2 vehicles in at YPO, which is the Yorkshire Purchasing Organisation, delivering supplies to the schools. With the vehicle itself, you can see some of the specifications up on screen here. So as I mentioned earlier, it's a 19-ton rigid, which has got a wheelbase of between 5.3 and 5.85 and a payload of between 7.3 tonne and 9.3 tonne. Electric power takeoff of 22 kilowatts, which was important because 8 of the vehicles had temperature controlled bodies and all vehicles had tail lifts. And we had a usable battery capacity of 254 kilowatt hours and a nominal range of up to 280 kilometres. From a charging perspective, this vehicle is able to take a DC charge of up to 150 kilowatt, which would charge the vehicle from 20 to 80% in an hour, and can also utilise AC charging up to 22 kilowatts, which is perfect for overnight charge. And now I'd like to hand over to Tom and to Chapper to go through some of the key learnings and some of the results of the project. Thank you.
Right, my name is Tom Allerton. I'm from Cenex, which is one of the leading organisations in the UK doing research into the decarbonisation of transport. And I'm going to talk about Cenex's role within the BETT project. So Cenex has been tasked with 2 main things within BETT. Our technical role is about collecting telemetry data from the BETT vehicles. So we put loggers in all of the vehicles to collect telemetry data, but we also collected data from the chargers, and we did surveys and interviews with the drivers and the end users to get more qualitative data as well. This was all fed back to our offices. So we have a data processing server where the technical information was fed to. We stored this, we processed it, and we analysed it to derive insights, which all then got fed into the dashboards and reports, and also went into events such as the one today. And that public engagement side of it is also critically important. So throughout the trial, we have had the BETT portal, which is a website that we developed to showcase all of the findings from the trial, which you can go and visit. Part of that included some live data, which was updated very regularly with all of the vital statistics from the trial. We also had lots of general information and resources about electric vehicles, which fleets who are interested in moving to electric alternatives could go and see what is involved in getting and running an electric vehicle. We developed 2 range and fleet planning tools, which again, fleet operators can go to and use to understand what the effect of running electric vehicles in their fleet would be. We have published 18 reports, the final one of which will be online in just the next few days, which is the final report summarising everything that I'm going to talk about today. But that also includes many deep dive and summary reports on many of the topics even more widely than what I'll talk about. And while not strictly public, we developed an end-user dashboard to allow the fleet operators to understand the operation and performance of their vehicles throughout the trial. We have attended 6 end-user events where all of the end users of the vehicles could get together and discuss their experiences. And we have made 2 presentations, including an entire seminar session at the Cenex LCV events over the last couple of years. And finally, we took part in the Green Fleet EV Rally, where one of the vehicles drove between all of the capital cities of the UK from Cardiff through to London, Edinburgh, over to Belfast and down into Dublin. So I'm now going to hand over to my colleague Chapa, who will tell you a little bit about some of the headline numbers and vital statistics from the trial.
Thank you, Tom. Hi, I'm Chapa. I'm from Cenex and I've been working on some of the monitoring and looking at some insights into the trucks and their operations. I will take you through some of the headline numbers now. So, as part of this trial, lots of data, lots and lots of data over the 18 months. We've had about 58 gigabytes of raw data taken from the loggers, which comes to about 42,000 data files, which comes to about 16 billion data points recorded, with 21,000 individual journeys from the trucks identified, and about 21,000 hours of vehicle activity, which comes to about 875 days, and that's with 8,600 hours of active operation. Okay, so collectively over the trial, we have seen that the trucks have covered about 287,000 kilometers of distance, which is roughly about 2/3 of the way to the moon from the Earth, rather astronomical. And the trucks have used 275,000 kilowatt hours worth of energy, which is the amount of energy to make enough tea to fill 1 1/4 Olympic swimming pools, lots of tea. And we've also found that we've saved 210 tons of carbon dioxide over the course of the trial. So, alongside the trial monitoring, we've also done some deep dives where we look into the data, the trucks and their operation, their energy consumptions, as part of deeper insights, which we published onto the BETT website. I'll take you through a quick whiz through them, like a highlight reel of them. If you want more information on these deep dives, they're all available on the website where you can look at the findings and the data in detail. So if we look at drive cycle efficiency and regeneration, just a couple of points to cover here. Drive cycle refers to the type of driving that the vehicles did rather than the classification of the roads they're on. So we split them into 3. We have rural, urban and motorway. Urban refers to driving which has lots of starts and stops, which you usually see in cities and busier areas. Motorway driving has more constant speeds and less braking, and rural is somewhere in between. Regeneration refers to the ability of the vehicles to use kinetic energy from braking to feed that energy back into the battery to be used again. So this first graph here shows that with urban driving, you can regain about 25% of the energy by braking. So for every 100 kilowatt hours used, you can gain back 25 kilowatt hours of energy back into the battery to use again. This next graph shows the drive cycles with the range on the top and the efficiency at the bottom. The clearer parts on the top of the bars that you see there show how the range and efficiency can be extended via the use of regeneration. So this is a graph showing the overall efficiency of all the vehicles and their range. We found that the efficiency of all the vehicles is about 1.1 kilometers per kilowatt hour and a range of around 270 kilometers, which is roughly around the range that DAF was expecting. So it's good that these vehicles are meeting their expectations. Just as a note, about 8 vehicles out of the 20 have a temperature controlled unit. It is labeled as refrigerated here. And you can see that in this graph, the vehicles with the temperature controlled unit has slightly lower efficiency than the normal vehicles. initially you may think that this decrease in efficiency is due to some of the power being consumed for the temperature controlled unit rather than propulsion of the vehicle. But if you look at the data behind the scenes, this actually is not the case. So we'll look at some of the things that affect efficiency of the vehicle, such as payload, the weather, and ancillaries, and we can see exactly why the vehicles with the temperature controlled units have a slightly lower efficiency. So this graph here shows the efficiency of the vehicles against temperature. So the green bars here show the efficiency of all the vehicles across the trial, across the duration of the trial, and the black line overlaid on there shows the temperature during that particular week. So two things to notice here. There is a clear dip in efficiency over the winter period when it's colder. This is expected. This drop in efficiency also happens in petrol and diesel vehicles. And the other thing to notice is that the efficiency is really strongly correlated with the temperature outside. So we can see that outside temperature is a big factor which affects the efficiency of a vehicle. Next, we'll look at ancillaries. So this shows the power consumption of the temperature controlled unit, and we've got some data from the cab heater as well. Again, the black line overlaid is the temperature outside. So the yellow bars show the base load consumption of the temperature control unit, so just what's always been used. That comes to about 2% of the power consumption. And then the actual use of the temperature controlled unit is showed by the red bars. You can see that there is an increase in temperature control unit consumption during the colder months as it's working to heat the cargo, since the unit tries to heat the cargo to about 20 degrees. If we look at this graph, about 4% of the consumption goes towards the temperature controlled unit, which is not quite enough to account for the difference in efficiencies we saw between normal vehicles and the temperature controlled vehicles. So moving on, if we look at payload, payload is also another factor that affects the efficiency of vehicles. This graph here shows all the vehicles, and the blue bars show the range and their average payload that we got from the telemetry data, and the red line underneath shows the unladen weight of the vehicles. If you look at the 8 vehicles on the left, you can see that they are roughly about 2 tons heavier than the normal vehicles. Those 8 vehicles are the vehicles with the temperature controlled units. If you look at the dark blue lines in between the bars as well, they show the average payload, and generally the 8 vehicles which have the temperature controlled units, they carry slightly heavier payloads compared to the normal vehicles. So if we look at the relationship between payload and efficiency, this graph here is split by the 3 drive cycles. You can see that generally there is a drop in efficiency as payload increases, which makes sense. Heavier vehicles require more energy to move off and do their journeys. So just taking into account everything that we talked about, so outside temperature, use of ancillaries and payload, the most likely reason behind the decrease in efficiency of the temperature-controlled vehicles compared to the normal vehicles is most likely due to the increased mass, because the unladen weight is about 2 tons heavier than normal vehicles, and they generally carry a ton extra weight during their journeys. From these insights, I think one of the main takeaways is that the effects of payload, temperature, and ancillaries on efficiency are quite useful for fleets, just so that they understand what they can expect in terms of truck performance under various conditions. Yeah, that was a quick whiz through some of the deep dives that we did. It was just to give you a little bit of a flavour of the things we looked at. If you want to look at things in more detail, there's plenty of reports on the BETT website that you can check out. I'll pass back to Tom now. He'll talk about some of the feedback we got from the drivers.
So thank you very much for that really insightful information, Chapper. So as I said earlier, in addition to the telemetry data, we also did surveys and questionnaires of the drivers to understand some more of the qualitative information. And I'm going to go through a flavour of the results that we got now. So we asked all of the drivers, both at the beginning of the trial and at the end of the trial, what their expectations were and what their experiences were of driving an electric truck compared to the diesel vehicle they normally drive. We asked them a number of questions, including questions about acceleration, performance, manoeuvrability, range, and such like. And as you can see from these results, for almost all of the questions, the drivers rated the electric vehicle either better or much better than the diesel equivalent. There are obviously a couple of answers where the result was a little bit less favourable, the obvious one being the range on a full charge, although we never expected an electric vehicle at this stage to have quite the range of a diesel vehicle, so that is an expected result. If I add a few more lines to the diagram, this shows how those opinions changed throughout the trial. So you can see that for some, such as acceleration, the answers that the drivers were giving at the end of the trial compared to what their expectations were at the beginning are actually quite significantly better. And that is also true for the majority of the answers, showing that once the drivers get into the vehicles, they actually have a better opinion of them than they did even beforehand. This is actually really important because if the drivers don't like the vehicles, it's going to be really hard to adopt them onto fleets. So this really shows that the idea of the drivers not liking the vehicles is a complete myth. Drivers tend to really love the vehicles, and that just shows that that isn't going to be a barrier to adoption of the vehicles on fleets in the future. The only one that is a little bit negative is truck reliability. However, the vehicle is in operation with fairly early versions, and there's always going to be some niggling, teething issues, which will likely resolve themselves over the course of further development of these vehicles. So, moving on to the fleet managers, we did interviews with all of them and asked them what the drivers thought and what their experiences were with the vehicles. So the first quote I have here is actually one that nearly every single operator told us, which is that the drivers love to drive the vehicles. And this reflects the answers that we got to from the drivers, which I showed on the slide before. And as I say, it's very important that the drivers like the vehicles, and indeed they do. One slightly unintended consequence of a vehicle that doesn't make any noise is it meant that some fleets were able to deliver to places that they couldn't do in a diesel vehicle. Certain places don't like it when you're driving loud diesel vehicles nearby, and this just opened up the possibility of being more flexible with when the vehicles were being operated. Again, going back to the theme of the driver's experience of driving the vehicles, the fact that they're so much easier to drive, there's no gears, the power delivery is smooth and the manoeuvrability is good, were some of the more specific reasons why the drivers said they like driving the vehicles. And it goes like a rocket. Again, drivers tend to like driving something that's more powerful than something that's just dawdling along, and they really appreciated the immediacy of the power you get from an electric motor. And also, the electric trucks attracted attention and they're great for marketing, which is really good for fleets that want to portray their green credentials. Having an electric truck on the road, and particularly when it's liveried up with the fact that it's an electric truck, is a really great marketing opportunity and shows that these organisations are trying to do something better for the environment. Of course, it's not always good, and there were some more negative comments. So one that we had was that the cab was quite hard to keep warm, which did negatively affect range. And actually our analysis showed that although it had quite a modest effect on range, clearly when you have a more limited range than a diesel vehicle, it is important to be as optimal as you can. And of course, the drivers really want the cab to be warm in the winter. So this is a potential area for development in future versions of the vehicle. Also, they'd like to go further, but they need somewhere to charge en route. All of our operators were using depot-based charging, and that's because it's very difficult to charge a heavy goods vehicle on the public charging network at the moment, mainly due to the physical size of the trucks not being able to get to chargers which are predominantly designed for cars. So this shows the importance of charging infrastructure on being able to extend the range of the vehicles, which in turn means it'll be much easier to adopt these vehicles into a fleet. And also, the vehicles were great, we were only let down by the chargers. And this reflects the fact that when there were technical issues, they tended to be more with the chargers than the vehicles. And some of that was not just physical charger, but it might have been the communication or the back end of the chargers that was not working properly. But it does really demonstrate the importance of having fully functional chargers in order to make sure the uptime of the vehicles is what the fleets need to be able to rely on them. Of course, if you can't charge a vehicle, you can't drive the vehicle. So it's just as important as the reliability of the vehicles themselves. And also, technical issues, when they did happen with the vehicles, did take longer to resolve than they were used to with diesel vehicles. But this was partly due to a smaller number of technicians which were able to work on electric vehicles. But this is a problem which is likely to start resolving itself once electric vehicles become more common and there are more trained mechanics to deal with those issues. And finally, I've put another comment that was very specific but came from a lot of vehicles, and it's that the relatively early version of the truck that the drivers were using had an analog state of charge gauge, which was actually quite difficult to read, and it made it difficult for the driver to understand how much range was left in the vehicle. And this contributed to some issues of range anxiety. Although range anxiety wasn't a major issue that was seen during the trial, having good information in the cab about how far the vehicle can go is really useful and does mean a driver can get the most out of the vehicle and be comfortable they can take it home. Now, it's good to say that the latest version of the vehicle from DRAF has a far improved dashboard which shows this information a lot more clearly, but I wanted to put this here because this will have coloured some of the results that the drivers gave to us and might explain some of the slightly negative comments around the range and reliability of the vehicle. Moving on, we did some analysis looking at the business case of operating electric heavy goods vehicles versus a diesel. We developed a calculator which looks at what the total cost of ownership of an electric vehicle is compared to a diesel equivalent. And this is available on the BETT website. And it allows you to put in your own numbers and own figures to decide what the total cost of ownership would be with your particular situation. So what I'm going to show here, though, is an example of one of the bits of analysis we did looking at electric vehicles which are similar to the BETT vehicle, so a 19-ton rigid truck compared to an equivalent diesel vehicle. In this analysis, we assumed a 7-year ownership period and 50,000 kilometres annual distance, which is roughly what this kind of vehicle does on average. And what we did was looked at all of the capital and operational expenditures and totted them up for both the diesel and electric vehicle. And we used two different scenarios here. So the top graph shows what would happen in a hypothetical situation in the future when you do have significant amounts of ability to recharge at public chargers. Now, recharging on public chargers is currently relatively expensive compared to charging at the depot. So in this particular scenario, we can see that the total annual cost of ownership of an electric vehicle increases from around £49,000 for a diesel vehicle to 56 for a electric. So it's slightly more expensive than operating a diesel vehicle. However, if you change to the scenario that the BETT fleets were operating in, where all charging happened at the depot, you can reduce the cost of your charging, and that swings the results towards the electric vehicle, so it's actually slightly cheaper. The total cost of ownership of the vehicle is less than the diesel vehicle. It is worth noting, though, that these costs do include VAT, and one thing we saw over the course of the trial was that electricity and fuel prices varied wildly, and they will continue to vary. So if you do this analysis in the future, again, the numbers are likely to change. So we do encourage you to download and have a play around with this calculator and put in your own prices for this. What we did do, however, is try to understand what the sensitivity of those different factors are to the total cost of ownership. So we actually looked at 21 different factors within our model, and these factors cover policy, operational and external areas. And the graph on the right-hand side here shows the impact of each of those 21 policies. Now, this doesn't show all of them, but it does show the biggest ones. And as you can see, the ones towards the top are the electricity price for refueling and the diesel price in first and third place, with the efficiency of the vehicle in second place, just showing how important the fuel prices are to the total cost of ownership. The middle one there, the efficiency, that is something that the operators potentially have some control over, maybe giving the drivers more training on how to get the most efficient driving from their electric vehicle is something that can be considered. Finally, we looked at the environmental benefits of an electric vehicle. So we did a life cycle assessment of the carbon equivalent emissions. And a life cycle assessment looks at not just the burning of the fuel or generation of the electricity, but looks at the carbon emissions over the entire life cycle of the vehicle, starting with the production phase, which includes the raw material extraction and the development of the components that actually go into the vehicle, through to the use phase itself. So this is the burning of the diesel or the generation of the electricity. And finally, looking at the end of life emissions. So this is the disposal or recycling of the components once the vehicle has ended its useful life. So a quick look at the results here. The graph on the left-hand side shows the emissions from the production phase. And the first thing to note is that the electric vehicle is fairly considerably more carbon intensive than a diesel vehicle, and that's almost entirely due to the battery. So it's around 1.6 times more carbon emissions. The top right-hand graph here shows the use phase emissions. So in order to give a bit more granularity to the results, we looked at 3 different electricity grids to represent different amounts of carbon intensity of those grids. So our baseline case was the UK, which has a moderately decarbonised grid. And if you were to charge your vehicle on UK electricity, you can save just over 50% of the emissions compared to a diesel vehicle during the use phase. If, however, you go to Denmark, they have a grid with lots of renewable energy and very low carbon intensity. You can save nearly 90% of the emissions compared to diesel. However, a country such as Poland still has a lot of coal generation. It's a fairly dirty grid, and if you were to use Polish electricity to charge your vehicle, you'd actually end up emitting more carbon emissions than you would with a diesel vehicle. And this demonstrates how important the electricity you use to charge your vehicle is to the overall emissions of the vehicle. And finally, at the bottom there is the emissions from the end of life, and actually these bars go downwards because by recycling or reusing the materials, you essentially offset emissions from another product down the line. And there is great opportunities from the battery in particular, given how insensitive it is to generate, to reuse that possibly in stationary applications after it's finished its useful life in a vehicle. Putting that all together, across the total life cycle of the vehicle, the graph on the left-hand side here shows the total carbon emissions over the lifetime of a vehicle. The first thing to note is the grey part of the bar, which is the use phase emissions, dwarfs in most situations the production phase, which means that even though the production emissions are a lot greater for battery electric vehicles due to that battery, because of the much lower emissions during the use phase, because of the cleaner electricity grid in the UK and Denmark, those emissions are reduced by about 40% and 70% respectively. Of course, if you have a dirty grid, you feed dirty electricity into your truck, those carbon emissions do go up, which again just shows how important the source of your electricity is for the overall carbon emissions. Now, in our example here, we're using a typical 50,000 kilometre range for a truck such as this. And if you operate your truck like that, then you actually have a carbon payback of somewhere around a year. Compared to a diesel equivalent, providing you're using a UK or Danish grid mix. The BETT vehicles haven't gone quite 50,000 kilometres per year, but this shows that even with lower mileage per year, the payback is still within the 7-year lifetime of the vehicle. So that's everything from me. I just want to say that there's much more detailed information on the BETT website, so please visit that and you can look at many of the reports we've published to get far more detailed information.
So I'm now going to come to Graham Bunting to give us some of the operators' input. I recognise, sorry, that Graham couldn't be with us here in the studio, but nevertheless his insights are just even more valid, just as valid as they would be if he was here. So Graham, just give us some of your initial feedback into what you've heard, and then what your thoughts are from the trial. I've just got to get the tech to link you back in, so just give me a second.
Okay. Can you hear me? Because I've lost all sound from you guys, so hopefully you can hear me. Okay, so firstly, thank you for inviting us along to this webinar. I think it would be very safe to say having the opportunity to join this trial was certainly very eagerly anticipated by both Unipart Logistics and by our customer SCCL, because it was part of what has been a very groundbreaking exercise. I think it would be safe to say that. We have 8 of the 19-ton rigids based in 4 of our regional distribution centres. And I think, our initial findings would be that we expected some teething issues, and obviously there were. And I think it was Adam who mentioned earlier, the number of trained technicians probably did slow down some of the fixes, but they've been incredibly reliable. We initially trained 4 drivers per rigid, so 32 drivers in total to drive the vehicles for some consistency. And it would be safe to say now, 18 months down the line, we have a much greater number of drivers driving them, and still a list of our team who want to be able to still train how to drive them. So they've certainly been very popular with the drivers. And I think Tom touched on this, that of the driver expectations from the start, and I think of the 12 expectations that we set, 9 of them, the drivers have said are far better than they originally expected them to be. And when we talk of range anxiety, yes, there was, in the early days, there was some range anxiety. I think we can safely say now that that is very, very limited, because the drivers who do drive them now are very aware of the distance that they can travel. And I think, we've touched on this already. Our vehicles are very different. They have a fridge on them, and not to keep products cool, as you quite rightly said. We carry all of our products between 15 and 25 degrees, so they are basically warming the vehicles, only cooling in very high temperatures. But of course, in the UK, we don't come across that very often. They've got the insulated bodies, of course, to keep the temperature, and they've also got a tail lift, so they start without anything in the back of the load area, heavier than a standard rigid would. And we predominantly make deliveries to hospital trusts in cages, and those cages can vary in weight as well. So from a performance perspective, the figures that we have, we can probably run around about 145 miles on a charge, fully laden, in the daytime. In the summer, that would probably dip to around about 110, 120 miles in the winter, and probably dip a little bit more at night. But then again, we've got all of the headlights on, etc., etc. So not a massive difference between day and night, but certainly some differences that we've noticed between winter and summer. But across the piece, we've travelled 230,000 kilometres roughly in these 8 vehicles, and we've made over 6,000 deliveries. And I think the main issue that we have come across this period has been more around the issues with the chargers than with the vehicles. As I say, the vehicles have been incredibly reliable. They're very popular. Everything that Tom said around the driver's feedback, I'm sure there was a lot of NHS supply chain feedback in there, going like a rocket. The takeoff, hill starting, and again, another great point. Obviously, delivering to hospitals, we deliver 24 hours a day, delivering at night time, where we aren't able to take a diesel vehicle in because there is a ward very close to the delivery area. Of course, we can take the electric trucks in because they are completely silent. So, I think we would sum that up as been a very, very successful trial.
Very good. Thanks a lot. Thanks for Graham for joining us. So let's get to it, because there's lots of questions that have come in about the reliability. Graham's mentioned it there. Come on, Adam. What was the issue? Were the problems with the trucks, or as Graham's mentioned there, it's the chargers that's been one of the issues. What are the? We don't need to go into the details of what the actual issues were, but what were the learnings? Because that's what this trial is about. What were the learnings?
Yeah, sure, and exactly that. The whole purpose of this trial was to share a transparent view on how to run electric vehicles, warts and all, to coin a phrase. And I think it's important that we can highlight what's good about electric vehicles and what we as an industry need to tackle and improve upon to roll this out at scale. So some of the issues potentially were quite small issues that are magnified because it's an electric vehicle and not an ICE vehicle. So it's around the knowledge from staff, from technicians, from our internal teams here in DAF. It's about replacement parts. It might be something quite simple, but they're not readily available as quickly as a component for an ICE vehicle potentially could have been. And then when it comes to infrastructure, of course, I think that is the key learning here, because the importance of the reliability of the infrastructure is paramount to the industry, whether that be private or public. You know, if the charge is down, the vehicles ultimately can't go out into operation, and that's not something that we have at the moment in the ICE world or the diesel vehicle world. So it does certainly highlight the importance of having a reliable infrastructure to support the trucks, and again, some invaluable experience and learnings that we've been able to gather from this project.
I think one of the things, having spoken around this project previously, was the service level agreements with the charge point suppliers, which were perhaps there were assumptions made that actually when you got into the weeds of it, needed a bit more attention, and to ensure that the charge point providers are available to maintain that, maximise the uptime of the vehicles.
Yeah, again, I think we've experienced a lot of valuable learnings from that. A number of issues can be remotely diagnosed, but not necessarily fixed unless there's people within sites and locations that are equipped and comfortable with going and turning on and off the charger, or opening it up, for instance. So there's a lot of valuable learnings around the training required, both within the businesses and the operations that the infrastructure is being placed at, and within our internal teams and the communication between that and the hardware providers.
Okay, we've got lots of questions coming through, but excuse me, before we go on to those, I want to, Tom Chapper, utilisation. I know there's a question that's been asked about this, but also just from my own observation, 287,000 kilometres sounds like a lot, but 20 vehicles, if you divide that down per vehicle, it's about 14,350 kilometres. I've had my calculator out this morning on the train on the way up here. That's not a lot for vehicles that have been on 18 months of operation. Why? We know that some of the vehicles were laid up for a while, but we've identified what the charger issues are. What's going on there?
Yeah, that's certainly part of it. It's worth noting there's a big variety within that. Some vehicles have done well over 30,000 kilometres, others a lot less. Some of it's just due to the nature of what those were doing. Some of the operators were doing very, very short journeys, so naturally didn't have as far to go. And indeed, some of it was due to some of the issues we had, the charger issues, which meant some of the vehicles were laid up for extended periods of time. And also there was a little bit of the operators just trying to understand the vehicles. Many of them said that they didn't want to push them too hard at the beginning while they were still understanding what their capabilities were. They wanted a very gentle dip into the world of electric goods vehicles, because for many of them they'd never operated an EV before on their fleet, so they wanted to understand what it could do. And as Graham said, that range anxiety did start to evaporate over time as they got more confident with how far they could go and started pushing them further.
Very good. Graham, I'm going to come to you just on that point as well around utilisation. Just to get some of your thoughts, you've just briefly give us, did your utilisation improve as you became more familiar with the vehicles? Just let me get the tech too.
Yes, indeed. So we started in a limited capacity for the first few weeks, with taking them out for 40 miles, then we would take them out for 50 miles, then we would take them out for 60 miles, and we just kept pushing and pushing and pushing until we got to a comfortable place, I think, and that was around about 120 miles. But what we also did as well, we would bring them, back to the RDCs, having maybe done around about 120 miles, and with a relatively local then delivery that may be just between 5 and 10 miles away, so the opportunity for another 20 miles without the vehicle being a long way away from its base. So that's how we grew the range until we were confident around the numbers, and as I say, we landed at around about 140 miles, been the comfortable distance. And then we planned these vehicles onto those, and I think picking up, I said it earlier, the 8 NHS vehicles, of which proudly one of those They're all identical. Sits currently behind me, bearing its fantastic BETT NHS livery. You know, we've done 230,000 of those kilometres in those 8 vehicles. So you know, we certainly have used the vehicles to a great extent.
Very good, thank you. Thanks for those insights. And I think that's sort of where the utilisation, it is a process of familiarity that sort of improves the utilisation. Interesting that he's used nearly all those 287,000 have come from those 8 vehicles. So that shows that some of the others have got some work to do to increase that. It should have been over 500,000 this trial by the sound of it. But anyhow, regeneration, that was an interesting comments that you made there. We hear it a lot when we speak to operators, that when you get into operational duty cycles, you start to get a range of vehicles and charging regimes that are way beyond what people expected. I think in cars, we've come to the point where we pretty much dismiss trucks. It's, if anything, could be extended. Chapo, any observations there?
Yeah, I think the regeneration is a huge advantage of the electric trucks. I mean, we saw that with urban driving; they regained back 25% of the energy. So, yeah, extending the range and the efficiency of the vehicles. And one of the things that we mentioned with driver feedback, especially at the beginning of the trial, was range anxiety, and that's one of the things that can help buffer that a little bit. But yeah, again, huge advantage. Also reduces, you know, the amount of charging that you might require when you come back. But yeah, I think it can really help with drivers' confidence.
Yeah, and I guess not only that, but you might not need bigger batteries, because I think we were talking earlier off camera about the you know, most of these vehicles, when they came back to charge, got 50% range still, or 50% battery capacity.
Yeah, exactly.
Still left. So that gives you lots of opportunities, doesn't it, Adam?
Yeah, certainly. You know, with that phase 2 electric LF that this project that supported this project, there was only one battery configuration available, so they all had 282 kilowatt hour capacity. With our next phase of vehicles, so the XB, which has superseded the LF, we offer that vehicle now in 141, 210 or 282 kilowatt hours, depending on the operation that the vehicles are going in to support.
And that was a direct benefit of being on a trial like this, that you're able to then start to flex around that.
Most certainly, yeah. Some of the findings from this project enable us to see that actually having a more configurable vehicle would offer advantages from a TCO perspective and, of course, a payload perspective. So it now enables the vehicle to be suitable for even more applications and more operations, which is what we want to see.
Right. And I note the seasonality variances that you mentioned in the data there, Chapa. But I think we've seen those seasonality differences over the years on diesel and any other powered sorts of vehicles. What I'm really keen to understand is there something going on with battery electric vehicles in temperature, in different temperatures, that is even more profound than you would get with, you know, the sort of general energy impact of diesel vehicles? What's going on there with batteries? Do you see that starting to come through?
Yeah, well, as you notice on the graph that Chapa showed, the temperature has a massive impact in the efficiency of the vehicles, but that is also something that you see in diesel vehicles. You just might not notice it quite so much because diesel vehicles have such high range and you can refuel them so easily, you don't care quite so much about it. But it is something that when you have a smaller range and recharging is a little bit more time consuming, that you need to consider. But certainly the batteries are a factor in that. It's something that is good that we've modelled, because what our modelling shows and what our analysis shows is just what the scale of impact that is. And that's really important if you're a fleet operator and wanting to operate these vehicles, is to understand what the real range and capabilities are. And as Graham said earlier, they've done put a lot of effort into understanding the difference between winter and summer, because that does make a difference. So you need to know when the driver leaves the depot just how far they can go. So doing that analysis gives the end user a lot more confidence in what the capabilities of the vehicle are when you do have a lot less range available than on a diesel vehicle.
Strikes me, looking up the data as well, Adam, as an opportunity for development around cab heaters as well, isn't there? It seems like that could be a new area of development.
Yeah, certainly. I think going forward, maybe heat pumps come into play to support that. At the moment, it's driven by the 24-volt batteries that look after all the auxiliaries in the cab, which obviously feeds off the main batteries. So I think heat pumps going forward will certainly feature. If I may just dovetail onto the question that Tom answered there, is that when we talk to customers, it's no longer theoretical. We've got real world data that we can refer to, which enables us, when doing feasibility analysis, to look at the impacts of the different seasons on the vehicle and build that into the user case at the beginning, which we always focus in on the road networks, ambient temperatures, how far the vehicle's needed to go, and make sure that it is fit for purpose over the duration of the life that customer needs the vehicle for. So again, just to emphasise the importance of what we've learned from the project, really.
I'm just coming down to some of the questions here, so let's just get the laptop up and I can go through and put my new glasses. I have to make sure I can see properly. Quietness of electric, so this is one from a chap called James Fawcett, who's on the call. Quietness of electric trucks enabling out of hours, nighttime deliveries is always one of the things that's put forward as a big pro for electric vehicles, although it makes the point, it's more of making a point than a question. Most of the noise caused by deliveries at night are from the ancillary equipment or the driver's radio or slamming the door than the vehicles. Anything to say on that?
Just that exactly that. There are an awful lot quieter than their ICE equivalent, which certainly has advantages in operations such as hospitals and collecting dustbins and things like that, so that are generally done sort of early in the morning when residents are still attempting to sleep. So yeah, some clear benefits.
Were there any outright compatibility issues with chargers used which would prevent the vehicle from charging? Even if was it pretty straightforward, the compatibility issues between the chargers?
So it's important to do those introb testing at the outset to ensure that they are compatible and do work, and that's part of the commissioning of the infrastructure units when they're put in, to ensure that those sorts of things are talking to each other and connected in terms of a service.
Okay. What else have we got here? So that was asking which make and models of charger did drivers report having the most issues with, but I guess you wouldn't want to, or maybe you would mention those.
All of the chargers
Right.
were the same for this particular trial. So they were all PACCAR branded chargers from one of our suppliers.
Right. Okay. HVO, would the life cycle analysis comparisons have made much of a big difference if you've used HVO? Presumably you've used the regular pump diesel for the life cycle analysis as question.
Yeah, it's not an analysis that we did on this particular occasion, but thinking back to some of Cenex's previous work that we've done, there is a small benefit, but it depends on the source of your fuel ultimately, and there's a lot of variations you can have. So it depends very much on the application and,
right,
and
the
how you do it.
feedstock, etc.
Exactly, yeah.
Okay. Question from Darren Newman, old friend of Freight Carbon Zero. Diesel prices seem very high. It's a question we had over lunch. VAT, why did we include VAT in those diesel price numbers?
So the prices we put there were just some examples. The calculator is available to download, and you can put your own prices in. So those are just some examples. I think it would be good to do that analysis without VAT as well. But the big thing that we've seen over the course of the trial since around March or April last year is that both fuel and electricity prices have changed immensely during the course of the trial. And it's been a bit of a scramble to try and keep up with what the latest fuel prices are. They're changing all the time. And if you did this analysis in 2 months' time, the answer would be completely different again.
I guess we're seeing a lot on flexible tariffs and all manner of stuff being offered these days. For
absolutely, there's flexible tariffs. It depends whether you charge at night or during the day, whether you've got any embedded generation generation. So the prices are very much dependent on each individual operator. And that's partly why we opened up the calculation tool for people to download and put their own numbers in, because it is very much an effect for each individual operator.
Very good. And they can access that via the website, which we'll send to everybody after the call.
Absolutely, yep.
Can you explain how you calculated the capital and depreciation? I think I raised the point when we were chatting earlier about the difference in capex between the depot-based vehicle and the on the road. Is it possible to get that slide up just to ask the AV team if they could?
Yeah. So
just give us a second. Probably go back about, I don't know, 8 slides, something like that.
2 up.
That's it. That's
one,
perfect. Yep. So
Yeah.
if you look, looking at the capex, you've got 12,311 for the public charging and a bit more for the depot-based one. Go.
Yep, so what I didn't explain at the time is the capex there covers both the electric vehicle and the charger installation. And for the bottom one, where we've had more depot charging, we've assumed you need a more powerful charger to do that depot charging. So there's a higher cost of charger, which is why the capex there is a little bit higher. Also, we believe there'll be a higher residual cost of the vehicles, the electric vehicles compared to diesel vehicles. Residual value, sorry, of the diesel vehicles, so of the electric vehicles at the end of their life. So that actually helps slightly equalise the capex of the diesel and electric vehicles.
Right. Is this your RV, is it, Adam, that you're putting behind these vehicles? Can you just pass it in there? Because that's an interesting point, isn't it? That you can play around with RVs. People are talking now about guaranteed RVs back on the scene again with the Green Finance Institute put out their report last week.
Yeah.
What give us a little bit of your thoughts on RVs, either based on this experience or other?
I think to begin with, it was difficult for manufacturers to go down the route of offering a residual value. I think going forward, many are, including us as we move forward, and those residual values are very much going to be based around the consumption of the vehicle and the operation that it's going into, and of course the battery state of health at the end of that operation as well.
Which you'll be able to monitor through the vehicle as well.
Correct. Yeah.
Tom, do you want to say anything on that?
Yeah, this is something that has featured in one of the previous reports we've published. We were looking at the state of health of the battery, and it does vary by vehicle and how far it's gone, but actually we've seen a degradation of less than half what DAF thought it would be. So it's actually really positive, and it shows the benefits of those LFP batteries.
Sorry, just because I'm just, as you're talking about that, I'm looking at a question that's asking around this, and I'm not sure I caught what your answer was, whether it answers the question or not. It says, what was the average charging power, and did you see any battery degradation, range degradation over the time of the trial, or is it a bit short? I don't think it was quite that wasn't quite the answer you were giving.
No, so the first one we had both 150 kilowatt chargers, or I think 120, and 22 kilowatt AC chargers. So depending on what the operation of the vehicles was, different end users took different chargers. In terms of degradation, yes, we did see some degradation. And as I just said, it was quite a lot lower than what the worst case scenario was. However, it was a relatively short trial, and degradation is something that happens over a long period of time. So ultimately, we can't say too much on that yet, and we'd have to monitor that over another few years to really understand what that looks like.
Adam, anything to say on that?
Just to support that, really, we were working on 1 to 2% degradation annually on the lithium ferrophosphate batteries that we have in all of our vehicles, and you'll always see a steeper degradation in year one that will then level out in future years. So it's important to monitor that, of course, and we also draw upon experiences from the bus industry who do use LFP batteries in a lot of their vehicles. And speaking to some of those larger operators that have had vehicles out now for a number of years, they're still only experiencing 1% or less degradation annually. So all positive signs.
Right. Okay. And so let's have a look here. It says, price. Have you done a price comparison on initial purchase price? It's linked to the question I was asking earlier about capex. But what I hadn't realised is that you built the RV into the capex that you're publishing here. Can you give any? What are you looking at these days for chassis cab?
as a
Diesel
comparison,
versus electric.
ICE versus electric, you're still in the realms of 2 to 2.5 times more expensive for the asset,
Right.
for the electric asset over the ICE, which is why it's so important to really drill down into the full TCO picture and work out whether it is or isn't suitable for your operation now. And there are lots of reasons why it should be suitable now, not just financial but environmental benefits as well, which we obviously touched on here today.
Okay. And is it possible to do weight analysis versus range? You touched on it in the data here, assuming that's the sort of stuff that people would be able to surface using the data from the trial.
Yeah, absolutely. There is one of our deep dive reports on the website that we published several months ago, looking in a bit more detail at the effect of the payload on the vehicle. Chapa showed an overview of the graph today. But that's the great thing about the quantity of data that we've received, is it allows us to look very deeply at what that effect was. The answer is, as you would expect, a heavier vehicle obviously impacts range, but we can actually look at what effect that has and how that also varies by things like weather and ancillary usage and such like.
Okay. Question, is the vehicle data available for commercial usage by companies that want to use it and then adapt it into their own businesses, potentially for products or otherwise? Is that something that the trial makes available, or is this proprietary? Is it a question you've been asked by? You've been asked now, but
yeah. I suspect the raw data probably won't be published, almost certainly won't be published. Obviously, all of the reason for the whole project is to disseminate our findings, so all the findings are available on the BETT portal, and the intention is that industry can go and use those numbers to help them understand and remove some of the barriers to the adoption of electric vehicles. And I invite anyone that has more questions to contact me or one of the other members of the team to find out more information.
Okay, very good. We've got, I know I'm overrunning the hour, but we'll take another question or two. Can you explain, this is something, Chapa, that we actually took out of your presentation in the interest of time, and I'm going to put it back in anyway. Can you expand on the battery's typical state of charge when the vehicle came back to base, and the average dwell time on the charger to get back up to 100%? Some thoughts around that with AC and DC.
Yeah, so as part of our deep dives and our deeper insights, we did actually look at the charging patterns, the charging efficiencies of the vehicles and the batteries. We did find that I think it was 80% of the time when the vehicles did come back after their shift, their batteries were actually still half full. So essentially, you may not actually need such a large battery for the current operations. So that could be as you said, you've got the different configurations now for the vehicles, so they can choose what they'd like for their operations. And their downtime, most of the time, almost 100% of the time, they were able to charge their vehicles to full with their downtime that they had, I assume, which was overnight charging. I think most of the vehicles did use overnight charging just because of their shift patterns.
Very good. Okay, well, I'm going to start to draw it to a close now. We'll go with one last question here. So, has the cost of funding the additional capital been considered? This opportunity for a plug for PACCAR Finance here, Adam. What new services are you going to bring to market to continue to accelerate the charge?
Yes, I mean, we're looking at the development of the DAF dealer network, and there's a huge commitment that's already been put forward by all of the dealers to go on the journey to become electric truck centres, and that not only includes the training of technicians and sales staff, which we've alluded to earlier is key to keeping the vehicles out there in operation, but also infrastructure on their own sites as well, and the connectivity opportunities that may well bring to DAF customers and to the wider customer base that move into electric. So they've committed to a minimum of 180 kilowatt chargers on their sales locations to be able to support those customers. So there's a huge focus around the connectivity piece and the services that will be provided on the back of our electric vehicle portfolio. And PACCAR Financial, of course, are also now on offer to support the CapEx in terms of potential operating leases, etc., with the RV position that we've already discussed.
Very good. And so what happens to these vehicles now? I'll just bring it to a close. I think where do they go? I think some of them are being out on an EV roadshow and now rolling out on a training program, I guess.
Yeah, so post-trial, the idea all the way through the project was that the vehicles would be retained by the operators that have been utilising them throughout the project, and hopefully that still is the case in many instances. We've had a couple of vehicles returned to us, and that's enabled us to take part in events such as the Green Fleet EV Rally, which we heard about earlier by Tom. That really did identify or promote the capability of the vehicle and the need for dedicated.
So I think on one of those days you went over 500 kilometres on a single charge or something, is that right?
I think it was over 573 kilometres, yeah. So fantastic in terms of showcasing the performance of the truck, and also the need for dedicated infrastructure, which of course is an enabler to this and something we've already talked about as well. More recently, we've had two of the vehicles enter into what we've called the DAF EV Relay. One starting in the north and one starting in the south. Those vehicles have been moving around all of the dealer locations, over 34 dealer locations across 5 countries. And that's enabled the dealers to promote the electric vehicles internally. So the staff have been able to get hands-on with the vehicles, talk about the training development plans for next year, and what that journey to become an electric truck centre looks like, and also opened out to local customers who have been able to come in and listen to the dissemination of the BETT results, like we've done today. Those vehicles have been liveried up to show the environmental and financial savings that the project's produced, and that's liveried on the side of the vehicles, which looks superb, and interaction with local customers. So it's been a really successful event, which is still taking place throughout December and into January. We also added a fundraising element to it, so those vehicles have been collecting gifts on their journeys from dealer to dealer, and those gifts will be taken into children's hospitals at Christmas time.
Very good. Excellent. Okay, well, I think that's about it. Thanks a lot for your attendance, everybody on the call. Thanks to Tom, to Chapper and to Adam for joining us here in the DAF Trucks studio, and to Graham for beaming in and giving us his insights on the vehicles that have been in operation with Unipart. And thanks a lot to you for joining us today, and thanks for all your questions as we've come through. I'm sorry I haven't got a chance to answer them all. We'll take a look through and give some further feedback on those questions in due course. We'll be in touch after the webinar with the full recording for you, and any more information around the slides, and of course the BETT report when it is finally published in the next few days. I'm sorry about my coughing and snorting all the way through this presentation. I hope it hasn't distracted too much from it. I've been your host today. My name's Andy Salter, and thanks a lot for joining us, and we'll be in touch soon. Thank you.